Now we want to look at the reciprocal function y equals 1 over x. First, we make a table of the only basic points that you need to graph this function if you know how it behaves as x approaches 0 and as x gets very large. Okay, so you only need these points, 1, 1, negative 1, 1. It's very clear that if you put 1 into this function, you get y equals 1. Now, if x is negative 1, y is going to be negative 1. It also should be clear that this function is undefined for x equals 0, because division by 0 is not defined. Okay? I guess I better write that down. Division by 0 is not defined. So if you put 0 in here, you don't get a result. One of the things that I most hate to see on a graph of this function, because I have to penalize it very seriously, is for somebody to put the origin in as a point. There is no point when x equals 0. The origin is not a point on this graph. So you really want to be aware of that. Now let's talk a little bit more about what happens near the origin and why it wouldn't make any sense to have this function defined at x equals 0, besides the point that you can't divide by 0. Okay? If x is 0.1, what's y? Well, what does 1 divided by 0.1 mean? Okay, 1 over 0.1 means how many 0.1s does it take to make 1? And I'm going to say this means count, C-O-U-N-T, to 1 by 0.1. How many 0.1s does it take to make 1? Well, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. It takes 10. Okay? That's the reason 1 divided by 0.1 is 10. Not because your calculator tells you so, but because of what division means and what it means to divide by 0.1. Okay. Now, what does 1 over 0.01 mean? It means count to 1 by 0.01. How many 0.01s are there in 1? Well, you can count. 0.01, 0.02, 03, 04, 05, 06, 07, 08, 09. What comes after 0.09? You add 0.01 to that, you get 0.1. So we've just made 10 counts, and we've gotten only up to 0.1. If we want to get to 0.2, we're going to have to count 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, 0.20. Now that's 20 counts so far. 1 divided by 0.01 turns out to be what? You should be able to figure this out. Let's pause and think about it for a minute, see if you get it right. 1 divided by 0.01 is 100, because you have to count 100 0.01s to get 1. Also the number of pennies in a dollar. Okay, so that would be 100. Okay, now, 1 divided by 0.001 means you count to 1 by 0.001. Well, that would take a while. We count 0.001, 002, 003, 004, 005, 006, 007, 008, 009, 01. Okay? We need 10 of these to even get up to 0.01, and we need 100 of these to count to 1. So we're going to need 10 hundreds of these, or 1,000. Now you could actually do that, probably in about 20 minutes. You could count to 1 by 0.001. That would be the same, basically you get the same result as if you counted to 1,000 by 1s. So this is 1,000. Now think about what this is doing to our graph. Okay? As a matter of fact, let's go ahead and sketch a graph here. And let's enlarge this interval from 0 to 1. So here's 0 and here's 1. And let's go ahead and manipulate the y-axis, so this is 10. Now, on the scale of this axis, I've made unit points. 10 would actually be 10 times as high as this, up off the board, up about here. And you can't see where I was pointing, but you can imagine. Okay, now, if x is 0.1, well, where is 0.1? Well, 0.1, you take the interval from 0 to 1 and divide it into 10 equal increments. Well, let's see. Here's half. That would be 5 of the 10 increments. And if we take 1/5 of that, it's going to be around here. So if this, let's say, is 0.1. So 0.1, 10 on this graph would be at this point. Okay, what about 0.01? You have to have the 0.01, 100. So where's 0.01? Well, you have to divide this interval into 10 parts. Well, if I divide it in half, then there's 5 of those parts in this half. And if I divide that, it's just barely to the right of this line because of the thickness of the line. So to get to 100, now where's 100 on the y-axis? Well, it'll be 10 of these. There's 1, 2, 3, 4, 5, and 5 more. We're going to have to go up a little ways. Okay? 100 might be about here. So, and I don't want to let that mark go too far because I'm going to have to make a mark very close to the y-axis because my 0.1 is very close to the y-axis. And actually, it's even closer than I've marked it, but if I try to make it any closer, you're not even going to be able to see any space between the y-axis and this mark. Now, if I want to do 0.01, 1,000, well, in the first place, let's see, that's about a foot. To get to 1,000, I'd have to go 10 feet high. And to get 1,000, I'd have to divide this little interval here, and that little mark here, into 10 parts, and I can't do that. The chalk's too thick. And you wouldn't be able to see it even if I could. Well, we got pretty good resolution on that camera, but I still question whether you can see it. So that point's going to be 10 times closer than this one to the y-axis and 10 times as high. If I wanted to go to 0.0001, I'd have to go 10 times closer than that to the y-axis to get my x point. It'd be microscopic or close to it, and I'd have to go up 10,000 units. If this is a foot, it would be about 100 feet. Okay? And there's no limit to how close this number can get to 0. This number can get closer and closer and closer to 0. I'm letting it go 10 times closer each time because it's convenient to divide by a negative power of 10. You know, tenths, hundreds, thousands, 10,000s, 100,000s, millions, etc. But if we think about what it means to divide, think about what division means, think about the whole concept, we see that this graph, as x gets closer and closer to 0, is going to get completely out of control. It's going to go so high, pretty soon we'll be out to the moon, then we'll be out to the next galaxy. Of course, there's a couple stages between the moon and the next galaxy, but you get the idea. So the graph is going to have to look something very much like this, where this point out, okay, I was kind of blocking it, where this point out here is the 0.11. Now, if we bring that over to the scale of this graph, where 1 is much smaller on the x-axis and much larger on the y-axis, the graph is going to end up looking like this. Okay, and actually I didn't draw that particularly well. It's approaching the x-axis a little too fast. The y-axis not fast enough. But it's going to have this general characteristic. It's not a particularly accurate graph, but it shows the behavior. Okay, and what we have is a vertical asymptote as we approach x equals 0, and the asymptote switches sides from the left side to the right side. Okay, on the left it approaches negative infinity, on the right it approaches positive infinity. The graph also approaches 0 as x gets large, either in this direction or in this direction. So we have a vertical asymptote at x equals 0, and that's the y-axis, of course. Horizontal asymptote at the positive and negative x-axis. Now the horizontal asymptote on the left comes up from below, because if you divide 1 by a negative, you're going to get a negative, so the numbers are going to stay negative here. And it's going to approach from above for positive x, because as long as x is positive, 1 over x has to be positive.